All right, so today we're talking about the constant rate of change and direct variation. We're going to identify the proportional and non-proportional relationships by finding a constant rate of change and solve problems involving direct variation. So this first part says, a cat's heart beats about twice as fast as a human's heart. The graph shows the average heartbeat of a cat. So we are to choose 2 points on the graph and find the rate of change. Well, we could find these first 2 points. And remember, it's the change of y over the change of x. So that would be 4 minus 2 over 2 minus 1, which would give us 2. So we have 2 heartbeats per second. And then 2 says to repeat part A with a different pair of points. So we could do these next 2 points. And we would have 8 minus 6 over 4 minus 3, and we get 2. So we could take a look at that, and we would notice that no matter which 2 pairs of coordinates we have on that line, we would still end up with the rate of change of 2. And that means we have a constant rate of change. So the graph that we just did is a straight line. A relationship that has a straight line graph is called a linear relationship. Notice that the graph above, that as time increases by 1, the number of heartbeats increases by 2. So we take those points and we could put them on a table just for illustration's sakes. And we know that from 1 to 2, this is going along the x-axis, 1 to 2, 2 to 3, 3 to 4, we go up by 1. And then those points was 0 to 2, 2 to 4, 4 to 6, 6 to 8, go up by 2. And so that shows us that is a constant rate, a constant of 2. So 2 heartbeats per second. The rates of change between any 2 data points in a linear relationship are the same or constant. This is called a constant rate of change. So you could have lines like this, that would be a constant rate of change. You could have negative lines, that would be a constant rate of change, but not a curved line. That would not be there's no way you could have a constant rate of change. All right, so we have this problem here. It says a circular design on an internet advertisement has 2 circles, one that is decreasing in size and one that is increasing in size. Find the constant rate of change for the radius of circle 1 in the graph shown, then interpret its meaning. So we can, circle 1 is the green line. We can choose any 2 points on the line. So we could do 2, 5, and we could do 6, 4. And then it's the change of y's over the change of x. So that would be 4 minus 5 over 6 minus 2, which would be 1/4, or 0.25 centimeters per second. And notice that it's negative. So that means it's decreasing at a rate of 0.25 centimeters per second. Okay? So very similar to what we did just finding the rate of change. It just happens to be a constant rate of change. So same thing that we did in the last lesson. All right, let's take a look at this one. So it says some linear relationships are also proportional. That is, the ratios of each non-zero y value compared to the corresponding x value is the same. So for example, if we have this line, we have coordinates 1, 4. Okay, so for example, we have 1, 4, we have 2, 8, and we have 3, 6. So these are ordered pairs. 1, 4, 3, 6, I'm sorry, 2, 8, and 3, 12. Okay, we can take those and put them in a table to make them easier to see. And then remember that the change is y divided by x. So the same thing here, we could take our y's and then divide them by the x, and we get 4. 8 divided by 2, 4. 12 divided by 3, 4. So that tells us that each one of these ratios has the same value. And if they have the same value, then it's proportional. Okay? It's proportional. Unlike this one, we could take these points and we could put them on a table. So we have our x, y's, and then we take our y divided by x, we get 4. We take our y divided by x, we get 3. This should be an 8. Take our y's divided by our x, and we get 2 and 2/3. Well, 4 and 3 and 2 and 2/3 are not the same value. They're not the same number. They're not equal. So this linear relationship is not proportional. So this line would be considered non-proportional. So they must equal in order to be proportional. All right. So it says the graph shows the cost of different amounts of trail mix. Determine if there is a proportional linear relationship between the cost and the weight of the trail mix. To determine if the quantities are proportional, find the cost of y divided by the weight of x for points on the graph. So we could take a point, 4, 14, and we can divide the y by the x, and we get $3.50. We can take 8 and 28, divide the y by the x, and we get $3.50. And we could take 12 and 42, divide the y by the x, and we get $3.50. Since the ratios are the same, the cost of the trail mix is proportional to the weight of the trail mix. Okay? So it's proportional. So Gina recorded the height of a tomato plant in her garden. Find the constant rate of change. So we need to find the constant rate of change. That's the first thing of the plant shown in the growth chart. So we could do here, all we need to do is pick 2 points, okay? So we could pick that point and we could pick that point. So that would be 1, 0, and the other one would be 3, 5. So I would have 5 minus 0 over 3 minus 1. That would be 5 over 2, or 2.5. So then it says describe what the rate means. That means 2.5 inches in 1 week. So every week the tomato plant grows 2.5 inches in a week. All right, then it says, so that's that one, then determine whether there is a proportional relationship to the plant in height. Well, again, we just need to make a couple of ratios. We have 1, 0, so we do y over x. It's got to be non-zero numbers. So let's do 5 over 3. That's going to give me approximately 1.67. And then we could do 5 and 10. So that would be 10 divided by 5, and that's going to give me 2. Well, already I don't really need to do any more points because I already know that these two are not equal. And if it's not the same number, then it's not proportional. So not proportional. All right. So now we're going to talk about direct variation. In the example above, the cost and weight both vary, but the ratio of the cost to the weight remains constant at $3.50 per pound. When the ratio of two variable quantities is constant, the relationship is a direct variation. The graph of the direct variation always passes through the origin and represents a proportional linear relationship. Okay? All right. So in the example above, the cost and weight both vary, but the ratio of the cost to the weight remains constant at $3.50 per pound. When the ratio of two variable quantities is constant, the relationship is a direct variation. The graph of the direct variation always passes through the origin and represents a proportional linear relationship. Okay. All right. So I might have already read that. All right. I was distracted. All right, here we go. So always passes through the origin. That means it passes through 0, 0, and it's always proportional. So that means it also has a constant rate of change. And that's what we're actually trying to find, is the constant rate of change to help us with these equations, the direct variation. So a direct variation is a relationship in which the ratio of y to x is a constant k. Okay, so we're going to call that the constant k. We say y varies directly with x. So this is the formula or the equation we're going to be using. Y equals kx. Okay? All right. So in the equation y equals kx, k is called the constant of variation or the constant of proportionality. The direct variation y equals kx can be written as k equals yx. So if I'm looking for k, all I have to do is divide the y by the x, and that's my k. In this form, you can see that the ratio of y to x is the same for any corresponding values of y and x. In other words, x and y vary in such a way that they have a constant ratio, and that is k. All right, so the time it takes to burn amounts of information on a CD varies directly with the amount of information. Write an equation that relates to the amount of information and the time it takes. Well, first thing we want to do is find the k. Remember, we can find k by simply going y over x. So we can pick any one of the points out of that chart. So let's just do the first point. We would have 10 divided by 2.5. Well, 10 divided by 2.5 is 4. So my k equals 4. All right? Then we can write an equation just like they did here. We put 4 in for the k, and we get y equals 4x. Now we can use that equation to make predictions. So let's say that we want to know how long it would take to fill a 700 megabyte CD. Well, that was in our k information. In our x information. So we just plug that into x, and we would have 4 times 700, or 2,800. So it'll take 2,800 seconds to fill the CD. We use equations like this to help in situations. So for example, if I'm making these CDs and I need to know how long it's going to take, do I have time to do something else? I know it's going to be 2,800 seconds. So as long as I'm back by then, I'm good to go. All right. So here's one that says, as scuba divers descend below the surface of the ocean, the pressure that they feel from the water varies directly with the depth. So write an equation that relates to the depth and the amount of water pressure. All right, so first I got to find the k. Again, I can use either point up here because it tells me it's a direct variation. So I can just simply use the first one. I can use 8.9 divided by 20. Well, 8.9 divided by 20 is 0.445. So I would say y equals 0.445x. That would be my equation. And then predict what pressure will be at 28 feet. Well, feet is my x, so I replace x with 28. So y equals 0.445 times 28. And that is going to give me y equals 12.46, or 12.46, I think it's pounds per inch squared. Okay? All right. If you got any questions, let me know. Otherwise, have a great day.